In this video, you'll be expected to take notes. If you don't have your materials ready, please pause the video and get your notebook and pencil out now. We're going to start talking about solving and graphing inequalities. The first thing we need to figure out is, what does the word inequality mean? You know the word equality, well, that means equal. And if you look at the word inequality, you have equality, and then you have the prefix in, which means not. If you think about um, efficient, if you're efficient, you do things quickly and precisely. If you're inefficient, you don't. So in means, the in means not equal. But it doesn't say like, oh, these are not equal, because that literally, what I just drew up there means not equal. Inequalities show a relationship. They show a relationship. They show if it's, greater than or less than. Is one more or less? That's what it'll show you. So think about what symbols are used for inequalities and what do they mean. We have this sign, which means greater than. I think you're starting to remember these. You know the next one is less than. But then you can also include a statement that means it's greater than or equal to. So the numbers could be the same or bigger, okay? So this is greater than and equal to. And of course, you have less than and equal to as well. I guess it's and or equal. In this situation, it could be both. It could be one or the other. Now let's look at graphing inequalities. You've done this before, I think. We're just using a number line. This isn't going to be like a coordinate graph, not yet. Maybe in 7th grade. Nope, 8th grade you will. Just taking a minute so you guys can write things down. If I'm going too fast at any point during this video, certainly you can pause it, you can rewind it, you can revisit any ideas that are tricky as many times as you want. Graphing inequality, and here in small print I wrote open versus closed circles. That is going to be your biggest challenge, is graphing. Whether you fill in the circle is what I mean by closed circle. I mean that it's filled in like that, or open, which means it's not filled in. It's not a closed circle, I guess. If you want to graph that x is greater than 6, where would that go? You'd see that I have this entire number line. I just put a 0 and a 6 on there. So x is bigger than 6. Can x equal 6? Not in this particular statement. So that's when we're going to use an open circle. It doesn't include that number, but it includes every number larger than it. And here's the problem. If I'm graphing on this, on any number line really, and here's a 6, what I want to say is x is greater than 6. It can be 6.00000001, right? How close can I get that dot and make it look like I'm still not including the 6? That's kind of a challenge, and that's why mathematicians have developed this open or closed circle. I like to think of the open circle as like it's a hug, but there's nothing in it. I am not hugging the number 6. I'm leaving this big open circle of my arms, and I am choosing everything greater than that. Think about how many answers we could have for this number. X could equal 7. I got that right here. X could equal 10. That's over here. X could equal, 18 billion, and that's over there as well. This is why we start graphing inequalities. We certainly do not have enough time to just write down all the different possibilities that X could be. And another one, X is less than 3. Same idea. Now, it's not included. It doesn't say that X could be equal to 3, so we're not going to include it in our circle. We're going to show that our ideas start at 3. And this could include 2.999 repeating, just about as close as you can get, but it doesn't include the number 3 right up next to it. That is what is called an open circle. It's not equal to that number, but it is greater than or less than it. So that's what we want to base our answer on. Now, some people notice a pattern that if the variable comes first, like it does here, the arrow in the inequality points that way, so we graph that way. This inequality points this way, so we graph this way. Well, that only works if the variable comes first. So let me erase and show you a different kind of example, which will be helpful to you because I know people recognize that pattern and they want to stay with that. What if I had 4 is less than X? Well, think about this number line. I'm going to put 0, and I'm going to put 4. Is X more than 4 or less than 4? Think about it. This says that 4 is less than X. And if 4 is smaller, then X must be greater. Do we go this way? That's not which way this arrow points. Let's think about it. Pick a number over here. Okay, 5, 6, 7, 8, 4, 5, 6. Choose 7. Does that make a true statement? 4 is less than 7. It does. Pick a number over here. Why not go with 0? Does that make a true statement? 4 is less than 0? It does not. So, I do not want to graph anything over here. I absolutely want to go this way. Now that's the opposite direction of what this inequality is as stated this way. So don't get caught up on whatever way the little inequality is pointing, that's which way you graph, because that is not the case. Let's take a look at what happens when you have a closed circle, or what kind of situations need a closed circle. It's when you have, it's when you have this equal sign underneath. So right here I have X is less than or and equal to 3. This is included. When the number is included, you close that circle in. It's almost like you're giving the number 3 a big hug. Your arms are around, but something's inside your arms this time. It is the number 3. And now X is less than that step. And on this side is where numbers get smaller. So I'm going to choose those. And again, you can check your answers always by taking a number from this side. If I put in a 1 here, is 1 less than or equal to 3? Certainly. Is 3 less than or equal to 3? Yeah, it's equal. And when we go back up here and look, I can't plug in the number 4 here because 4 is not less than 4. See what I'm saying? It's the same, which is why we have this open circle here, because the 4 is not included. Think of your circle of friends and 4 just isn't in there. So maybe the circle of friends is a better idea than a hug because you can't see me right now, hugging nothing. This is also a closed circle because the 6 is included. So we put a closed circle right here. Remember, by closed, I just mean filled in. And x is everything greater than that. So let's go this way. 10 would be over here. Is 10 greater than or equal to 6? Absolutely. So that is a good solution. If I wanted to just try, is 0 greater than or equal to 6? It is not. So it's good to identify that what you are graphing are just the possible solutions for x. What number can I put in to make it a true statement? Remember when we solved equations, we wanted it to be true. Okay? That's what we're focusing on again. Now, you knew it wasn't going to be this easy, just, making little circles and lines on a number line, right? We need to start solving inequalities, and let's start kind of easy. This is just like a one-step equation. So now let's look at my steps over here. Right over here, it says solve like an equation, letting the greater than, less than, all these little symbols over here are going to be just like your equal sign. They act like an equal sign. That's going to be your center of balance, right? Remember the balance beam that the little kids were on? Here it is. Here's Bobby over here. Let's give him some arms. Here's Susie over here. Okay, so that's what we're going to be focused around when we solve an inequality. Get this out of our way so we can do some work. Okay, let's take a look at this. X plus 6 is greater than 10. It's not as obvious, I don't think, as with an equation, but the steps are the same. If I am adding 6 over here, the opposite would be subtracting 6, but you have to do it to both sides. None of that has changed. This goes away, which was exactly our point. That's what we were trying to do. And this becomes 4. So x is greater than 4. Now let's graph that. You see my graph is not very detailed. It has a 0 and it has a 4. And the only reason I added the 0 was for reference, but I think these arrows on the end kind of tell you if you're going big or you're going home. Just kidding, if you're going small. Okay, so x has to be greater than 4. Now this is the situation where your x comes first. X is everything bigger than 4. Stuff gets bigger when I go to the right. Now, do I need an open or closed circle? That's going to be our biggest decision. Is 4 included? If I say 4 is greater than 4, is that true? It is absolutely not true. So I'm going to come over here, because I kind of scribbled with the green. I'm going to show you right on top that I would use an open circle to graph that. Now let's check an answer. What numbers are over here? 10, 16, 18 million. Sure, get ridiculous if you want. Let's plug that back in. Can I say that 10 is greater than 4? I absolutely can. Pick a number over here. 0 is 0 greater than 4? It is not. That's how you know you've gone the right way on the graph. I find that students will solve an inequality beautifully, but then graph it the wrong way. It usually happens when this is written, like I said, the other way. If I had, now this says the same thing. The big side here is facing the x, which it is here. So I'm saying the same thing, it's just written differently. But you really just want to follow the same way that caret is pointed. And in this situation, it's pointed to the left, but it's saying the exact same thing. I flipped everything. It's the mirror image. And this still says that 4 is less than x. So x, if 4 is less than x has to be bigger. And go that way. Let's try a two-step inequality. We're going to go pretty fast with these because you know all the rules to solve now. Certainly by looking at my graph, you'll know that the number 8 is involved. because if I'm multiplying by 2, the opposite of multiplying is dividing. 2 divided by 2 is 1. 16 divided by 2 is 8. X is less than 8. Open or close circle. Tell me, is 8 less than 8? If it's not, he is not part of my circle of friends. Put anything over here. So let's put in 4. Let's try that. What if I did put in 4? What's 2 times 4? That gives me an 8. And now remember, we're not talking about this. We're talking about my original green equation. So now I have 2 times 4 is less than 16. Is that a true statement? 8 is less than 16. That works. Okay. If I wanted to choose something bigger, again, I always choose an easy number. Let's go with 10. 10 is pretty easy. I would have 2 times 10 is less than 16. This is 20. Is that less than 16? No, it is not. So I did not want to go this way at all. I graphed it correctly. I have the open circle because, again, if I put 8 in there, these are equal. So this is not a true statement. Not true at all. And that's what we're trying to do. We're trying to prove that it is correct, or try to find the one number that makes it correct, right? So that's not going to work out for us. Here's another one, another gentle equation of multiplying. Opposite of multiplying by 5. You guessed it. Well, it wasn't a guess at this point. But there is something different about this equation. It's not just x is greater than, it's x is greater than and equal to. So open or closed, is 7 included? Ooh, wow, I said that it was 5. All these 5s on my mind when the graph clearly has a 7 right here. Okay, so is 7 a possible answer to this? Let's find out. If I plug a 7 in for x, just saying. Is 7 greater than 7? No, but it is equal to. So I need to include that 7. I need to fill that circle in and include it in my circle of friends. Now, everything is greater. X is greater than. So let's choose 10. Like I said, 10 is an easy number. If I plug 10 in for x, 5 times 10 is greater than or equal to 35. 50 satisfies this part of being greater than 35. And again, if I plugged 7 in, do we still get a true statement? Remember, that's what we're going for. We're seeking out the truth here. 35 is greater than or equal to 35. This satisfies the part about it being equal. So yes, that is a true statement. We can include 7 in our little circle of friends or our circle of possibilities. We can do 0, nothing less than over here, not even a negative number. Right? A negative number, we haven't quite tried to explore those possibilities. Even if it was like a -7, you would get -35, but this is easier to see. That is not true. This is a bunch of lies. Liar! Okay, we don't want that. We want the truth. And yes, we can handle the truth. So I think I just have a little bit more room here. Some people get really confused about what we're actually graphing. And hopefully in these examples, you saw that we're graphing all of the possible answers. If you go and say that, oh, actually, I want to show you a backwards type thing. If I add 14 is greater than 7x. Now the math on this obviously is pretty easy. Okay, we would divide both sides by 7, divide both sides by 7. And I know you're thinking, Miss Wilger, why is this so challenging? You're just going to come over here. I'm going to graph this. Here's your 0, here's your 2, and the little arrow points this way, and it's not included, so I'm just going to make my open circle and go this way. Seems okay. Let's check that. 14 is greater than 7 times 5. Well, we know in the last problem that 7 times 5 is 35. That is not true. It's not greater than 14. But the arrow goes this way, so my graph must go this way. Remember, I kind of told you it doesn't really work that way. Not if the variable doesn't come first. In this one, the variable doesn't. So you get the value first. And by value, I mean you get this number 2 on the first side, and then you read that way. So if 2 is bigger than x, then x must be smaller. Just read it this way. X is less than 2. So if you read it backwards, if you start wherever your variables and read it whichever way you need to go, you'll see the answer. X is less than 2. This is where stuff is smaller than 2, right? Now figure it out. Open or close circle, 2 is not a possible answer, so we're going to go there. Let's double check just to make sure. Let's check it with a negative 2. Okay, so now I have 14 is greater than 7 times negative 2, which is negative 14. And we all should know that 14 is greater than negative 14. We're not dealing with absolute values here yet. Following this video, you should have a quick Math Excel assignment to do. We'll talk more about this in class when we meet again.